Hello everyone. Let's now try to solve an absolute value equation that has extraneous solutions, or at least one of them. An extraneous solution means we find a solution the way we are supposed to, but when we check, it actually doesn't work. So let's do it and see how that looks like. As I said in previous videos, when solving absolute value problems, we need to get the absolute value term by itself. So in this case, it's multiplied by 5. So we need to divide everything by 5. Once we do that, we get absolute value already by itself. So this is 20 divided by 5, so that's 4x, and this here is 5. The absolute value term is already by itself, which means we can now split the absolute value into two linear pieces, because this is linear, right? How do we do it? As we did it before, we take what's inside the absolute value and we equal it to the negative of what's on the other side. So negative 4x plus 5. And the other one, we do the same thing, but we equal it to the positive of what's on the other side of the equal sign, which is just that, right? So what's inside the absolute value signs, we equal it to the negative of this, which is right here, and to the positive of this, which is right there. Why can we do that? Well, if we take this negative 4x plus 5, put it in here inside the absolute value. When we take the absolute value of it, it's going to come out without the minus. It's going to look like this. And then if we take this one, the positive one, 4x plus 5, and put it in here, when it comes out of the absolute value, it's going to look same as this one. So either way, this should work. Now what we need to do is solve two of these now linear equations. So first, let's just copy this and then distribute the minus here so we don't have parentheses anymore. So this is going to be negative 4x minus 5. Remember, when the minus comes in, everything inside changes the sign. So both of these were positive, so they become negative. Now we are ready for the next step. Next step, let's say we want to move all the terms with x's to the left hand side and then terms with the numbers only to the right hand side. So we will have to add 4x here, and we will have to, so let's add 4x here, and then let's subtract 4x here, and let's subtract 4x here. And then let's do something with numbers. Now numbers need to go to the other side, so we'll say minus 2 minus 2, so this goes away, and then minus 2 here, so why did I put it there? So minus 2, so this goes away too. Also these two will go away, right? And then this here will also go away. So we end up with 3x plus 4x, which is 7x, equals 2, and we have negative 7 here, negative 5 and negative 2 added together. In this case, right here, we have 3 minus 4x, which is negative x, equal to, and then we have 5 minus 2, which is 3. Now all we need to do here, let's change color once again. divide by 7 because this multiplication, right? And we get that x is equal to -1. In this case, we divide by -1, so we get that x is equal to -1. Oops. I mean -3. Now, we cannot say that these are answers yet because we didn't check. So let's check. And remember, for the absolute value problems, we always need to check. So right here, check. And let's do it first with the -1, this one right here. How do we check? Well, we just grab that number and we put it everywhere where we can find x in the original. So in our case, we copy the 5, start the absolute value, times, instead of x, we put -1. Plus 2, close the absolute value, equals to 20 times, there is x again, so -1 instead of x, and then plus 25. And we are checking it whether this is true or not. So now inside the absolute value, so let's just copy 5. Inside the absolute value, we have 3 times -1, which is -3, and then we plus 2, so we have -1 here. Equals, and again, we are checking. This is -20 plus 25. Now, 5 times the absolute value of -1. Well, absolute value of -1 is actually 1, so this is just 5 times 1 equals to 25 minus 20, which is 5, right? And then, well, 5 times 1 is 5, equal to 5, so this one checks. So we know that x minus 1 is actually a good one. Let's now check with the -3. So again, we just plug the values in, so this is 5, and we plug it always into the original, right? So this is 5 times 3, and instead of x, we put -3, and then plus 2, close the absolute value, equals, and we are checking that, 20 times -3 again, because that's our x in this case, and then plus 25 again. Inside the absolute value, we have 3 times -3, which is -9, and then plus 2 is -7. So this is -7, absolute value of that, times 5, equals, and we are checking that, 20 times -3 is -60, and then plus 25. Okay. And then absolute value of -7 is actually 7. So this is 5 times 7. And this here is -60. This is positive 25. So this is going to become a negative number, right? Negative number. Negative, in this case, -35, right? And then 5 times 7 is positive 35, which is not equal to -35, right? It's not equal, which means this choice right here, -3, did not work. So -3 is actually not a solution of the problem. So this is how we check for extraneous solutions. We always, when we do absolute value, we need to check, and then if we get a number equal a number, like in this case 5 equal to 5, that's a true statement, which means that's a good choice. -1 is actually a good answer right there. But if you get something like this, that's not true. This is obviously a false statement because this number is positive and this number is negative. Then we know that the choice we used is actually not a good solution, which is this right there, -3, right? I hope you liked the video. If you did, click like, click subscribe, and make sure that you don't forget to smile.